is Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Okay, today our topic is related to vector calculus. Already we discussed about vector calculus basic concepts. When we are using vector calculus, okay, if vector calculus means already we know that. What we know? Okay, ordinary differential equation, that is differential calculus. What is the difference between differential calculus and vector calculus? In the differential calculus, we have to take the function as f of x. Okay, that is y is equal to f of x. You have to differentiate y with respect to x. That is differential calculus. That is differential calculus. But what we discussed now, that is vector calculus. Okay, vector calculus. What is vector calculus? Once you observe here, the function is y is in terms of x, but in that vector calculus, function is in vector. That is f of x is f bar is equal to I bar plus j bar plus k bar. We are defining the differentiation on the vector. That is called as vector calculus. Okay, these are all we discussed in the previous session. Once again we remember that one. That is the difference between differential calculus and the vector calculus, and that related topics are okay, gradient and divergent. Gradient and divergent. These are also finished in the last session, and the next topics are line integral. Okay, integration of the vectors, that is line integral, surface integral and volume integral. In that session we discussed surface integral. Already we discussed in the previous class line integral. Once, what is the difference between line integral and surface integral and volume integral? Okay, first we discuss the difference between these two integrals. Line integral means it is single integral, right? It is single integral. That means for the given question is in terms of x, y, z, then we have to convert that as an x or y or z. Then we can integrate with respect to either x or y or z. But what about the surface integral? Surface integral means this is double integral form, right? This is in double integral form. That means integration either with respect to xy or yz or zx. Okay, this is surface integral. Double integral form. Simply this is double integral form, integration with respect to xy or yz or zx. Okay, and one more topic here, volume integral. Volume integral. What is the integration with volume means here, which is in the form of triple integral. That means integration with respect to x, y, z. This is the difference between line integral, surface integral and volume integral. Now we discussed surface integral concept. Okay, surface integral concept. Let us start with the definition. Surface integral. Consider a surface S. Okay, here what is the surface? You have to define with S. Let n denote the unit outward normal to the surface S. Let small n denotes the unit outward normal to the surface S. Let I be the projection of the surface x on xy plane. Okay, I be the projection of the surface. Okay, let us take that one surface. For that case, projection on xy plane. Okay, for that case, unit outward normal vector. Okay, already we discussed in the previous classes what is unit normal vector, greatest value of the vector, all. Okay, unit normal vector as here small n. Okay, and f bar be a vector function. F bar be a vector function defined in some region containing the surface S. Let f bar be a vector function defined in some region containing the surface S. Then the surface integral of f bar. Then the surface integral of f bar is defined to be Okay, here I be the projection on xy plane. For that case, very important for problems formulas here, not problems. Okay, very important formulas here. Double integral of, that is f bar dot n bar by modulus of n bar dot k bar into dx dy, that is equal to what? Simply what we have to write that as integral of f bar dot n bar ds. Here on the xy plane, let I be the projection on xy plane. For that case, formula f bar dot n bar by modulus of n bar dot k bar into dx dy. This is the first formula. Here R is the region, the surface. Okay, then continuation here. What we discussed, the surface integral means double integral form. That means either xy axis or yz axis or zx axis. This is the projection on xy plane formula. Next, we can define surface integral by considering the projection of the surface on the yz plane or zx plane. We can define surface integral by considering the projection of the surface on the yz plane or zx plane. For that case, what is the formula? That is double integral of f bar dot n bar by modulus of n bar dot I bar into dy dz. Okay, f bar dot n bar by modulus of n bar dot I bar into dy dz. This is projection on yz plane. For that case, what is unit normal vector? That has n bar. Then n bar is equal to what here? I bar. Okay, next projection on zx plane. Okay, next one, projection on zx plane. For that case, formula double integral of f bar dot n bar by modulus of n bar dot j bar dz dx. That is integration of f bar dot n bar ds. In that all cases, here what is ds? ds means what? Dx dy by modulus of n bar dot k bar. And next, here what is ds? ds means what? dy dz by, okay, modulus of n bar dot I bar. In this case, ds is equal to what? Okay, that is dz dx by modulus of n bar dot j bar. Okay, simply this is equal to what? This. These are the three formulas, very important formulas on surface integral. Next continuation. First question on the surface integral. Okay, evaluate integral of f bar dot n bar ds, where what is the function? Here f bar is equal to zi bar plus xj bar minus 3y squared z into k bar. Okay, and S is the surface. What is the surface here? X square plus y square is equal to 16. Okay, S is the surface. X square plus y square is equal to 16, included in the first octant between z is equal to 0 and z is equal to 5. Okay, here we have to directly given the question as evaluate integral f bar dot n ds, where we have to evaluate for the given question f bar is equal to zi bar plus xj bar minus 3y squared z into k bar, and S is the surface. What is the surface equation? This is x square plus y square is equal to 16, included in the first octant. What is the meaning of first octant? Between z is equal to 0 and that first octant is related to z axis, right? That first octant is related to z axis. That means how to consider the first octant here? Okay, already we discussed surface integral or we have to calculate either xy axis or yz axis or zx axis. But here particularly what they are given in the question, that surface is included in the first octant. That in octant is between z is equal to 0 to z is equal to 5. That means the first octant is related with z axis. That means that the first octant is related to the z axis. That means we have to calculate the given question. Okay, surface integral value either yz axis or zx axis. Okay, now I'll start with the answer here. Solution: the surface S is, what is the surface here? X square plus y square is equal to 16, included in the first octant. Included in the first octant between z limit points are z is equal to 0 and z is equal to 5. Okay, let us assume that the surface has pi. Okay, then let us assume that the surface has pi, that is x square plus y square is equal to 16. Okay, first I'll calculate the delta pi value, del pi value, not delta, del pi value. Why I am calculating del pi value? Here this is, I'll calculate the surface integral on integral f bar dot n bar ds is equal to double integral of f bar dot n bar. Here the surface is included in the first octant, means I'll calculate that as modulus of n bar dot I bar into d d sorry dy dz. I'll calculate the value on yz axis, surface integral value. I'll calculate it on yz axis. In the yz axis means here n bar is the unit normal vector and modulus of n bar dot I bar. Okay. Then first, let us assume that surface has pi, that is del pi is equal to. Okay. What is del pi? Here del pi already we discussed in the previous sessions. Okay, pi is here vector or scalar. Here pi is vector or scalar. This is scalar form. Okay, this is scalar form. That means here del means I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z into, what is pi here? X square plus y square minus 16. That is, here pi is scalar. If pi is multiplied with del, for that case what we call? That is called as the gradient. Okay, if del is multiplied with one vector, what we call that? That as the divergent, right? Okay, now we are multiplying with del with pi. Here pi as the scalar point function. Then I bar into dou by dou x of x square plus j bar into dou by dou y of y square plus k bar into, what is dou by dou? I'm sorry, here once again I'll write this step here. That is I bar into dou by dou x of, it is, what is pi? X square plus y square minus 16, right? Plus j bar into dou by dou y of x square plus y square minus 16. Okay, plus k bar into here dou by dou z of x square plus y square minus 16. X square plus y square minus 16. Then what is the differentiation? Okay, then I bar into, with respect to x, x square as 2x and y square and 16 as 0, right? That is I bar into 2x plus j bar into, with respect to y, x square as 0 and constant as also 0. That means y square differentiation is what? 2y. Okay, plus k bar into dou by dou z of x square plus y square minus 16. Is there any term with respect to z here? Is there any z term is there in the given pi? No. Therefore, dou by dou z of x square plus y square minus 16 is equal, with respect to z, that has 0. Therefore, del pi is equal to what? Del pi is equal to 2x I bar plus 2y j bar. Therefore, del pi is equal to 2x I bar plus 2y j bar. Why you are calculating del pi here? Here n bar is the unit normal vector. Generally, what is n bar? N bar is equal to del pi by modulus of del pi. For that case only, first I am calculating del pi. Next, what about modulus of del pi? Okay, del pi as 2x I bar plus 2y j bar. Right? Now, what about modulus of del pi? That is equal to square root of 2x whole square plus 2y whole square. Right? 2x whole square plus 2y whole square. That is the root 2x square means what? 4x square plus 2y whole square means what? That is 4y square. Okay, the root of 4x square plus 4y square. That is 4 into 4 into x square. Here what is common? 4, right? That's why I'll take under root 4 into x square plus y square. That is equal to how much here? X square plus y square is equal to 16. Okay, that is 2 into 2, 16. That is 2 into 4. 2 into 4, that is 8. Right? Xi bar modulus of del pi. Okay, 2 into 4 as 8. Right? That is modulus of del pi. Okay, modulus of del pi is equal to 8. Now I'll substitute del pi and modulus of del pi as in unit normal vector, right? I'm substituting now. N bar is equal to unit normal vector is equal to what? N bar is equal to del pi by modulus of del pi. Okay, that is what is del pi? 2xi bar plus 2y j bar by modulus of del pi means what? 8. Okay, na? For that, I'll take 2 common in the numerator, that the remaining part as xi bar plus yj bar by 8. Okay, therefore 2 ones are 2 fours are. That is xi bar plus yj bar by 4 as n bar. Therefore, unit normal vector is what? N bar is equal to xi bar plus yj bar by 4. Okay, next one, I'll write here. Then what is the formula here? We have to calculating on first octant within the, okay, between z is equal to 0 to z is equal to 5. For that case, I am taking the formula as let R be the projection of S on YZ plane. S on YZ plane. Therefore, what is the formula for that? Integral is f bar dot n bar ds is equal to double integral of f bar dot n bar into dy by dz by modulus of n bar dot I bar. Let us assume that as first equation or star. Okay. Here already we know that n bar. What is n bar? Xi bar plus yj bar by 4. And what is the given function here? F bar is equal to zi bar plus xj bar minus 3y squared z k bar. Right? Now I'm multiplying, that means dot product with both the vectors. What is the first vector? F bar, and the second vector as unit normal vector, right? That is F bar dot n bar. That is zi bar plus xj bar minus 3y squared z k bar dot what is n bar here? Xi bar plus yj bar by 4. Okay, both the vectors, then you have to, okay, use the dot product for both. Okay, here how to use the dot product for the both the vectors? Here I bar coefficient is what? Z, and here I bar coefficient is x by 4, right? Plus here what is j bar coefficient? X. Here what is j bar coefficient? Y by 4. Therefore, f bar dot n bar is equal to what? Xz plus xy by 4. Xz plus xy by 4. That is f bar dot n bar. Right? And next, what about n bar dot I bar? Okay. In that formula, I'll take first f bar dot n bar, and after that I'll take n bar dot I bar. Okay. That is n bar dot I bar means What is n bar here? Unit normal vector xi bar plus yj bar by 4 dot I bar. Okay, 4 dot I bar. That means here once you observe, if these two are also vectors, how to multiply both? Okay, then here I bar coefficient for the first vector as x by 4, right? And here I bar coefficient as 1. Therefore, x by 4 into 1. That is x by 4. That is n bar dot I bar. Therefore, f bar dot n bar is equal to 1 by 4 into xz plus xy, and n bar dot I bar is equal to x by 4. Now we know that each and every point of the formula, that is f bar dot n bar and n bar dot I bar. Then what about modulus of n bar dot I bar? Modulus of n bar dot I bar as, okay, that is modulus of x by 4. Okay, next we discuss that. Okay, now here we are calculating projection on YZ plane. That means we have to take the limit points on YZ, right? Already we know that Y limit points, okay, we know that Z limit points directly given in the question. What are the Z limit points are 0 to 5, right? Z limit points are 0 to 5. And what about the Y limit points here? This is Y. In YZ plane, if you have taken x as 0, what is the plane equation here? X square plus y square is equal to 16. For that case, if you are substituting x is 0, then y square is equal to 16. Therefore, y is equal to 4. Okay, I'm taking only the positive value. Why? Because here we are calculating on YZ axis. That means, okay, upper point as y is 4 and it starts from 0. Therefore, the limit points are y is equal to 0 to 4. Therefore, in YZ plane, if you are taken x is 0, we got y is equal to 4. Therefore, in first bracket, y varies from what? Y varies from 0 to 4 and z varies from 0 to 5. Okay, 0 to 4 and 0 to 5, right? Therefore, now we have to substitute each and every value in the first equation or star. Okay, that is the formula, right? Now I'm substituting there. Therefore, integral yes, f bar dot n bar ds is equal to, what are the y limit points? Y limit points are 0 to 4. And the z limit points are integration of z is equal to 0 to 5. And what about f bar dot n bar? That is, f bar dot n bar is xz plus xy by 4 into dy by dz by modulus of n bar dot I bar. What is that? That is x by 4, right? I'll write that step here. That is y is equal to 0 to 4 and z is equal to 0 to 5. X is common, that is z plus y by 4 and dy into dz by x by 4 only. Okay, here modulus means no need to take square root of. Here the modulus meaning is if that positive, if it is in negative value n bar dot I bar, for that case we can take that as positive. But directly here we got n bar dot I bar as positive only. That means here I'll write that as x by 4. Okay, here x by 4 and this x by 4 is cancelled, right? Okay, therefore integral y is equal to 0 to 4 and integral z is equal to 0 to 5 into, okay, function is y plus z dy dz. Okay, y plus z into dy dz. Okay, now I'll integrate first either with respect to y first or with respect to z. Why? Because here the y and z limit points are numbers only, not variables. That means either you have to integrate either with respect to y first or with respect to z first. Okay, then first I'll integrate with respect to y. That means here y square by 2. Oh, okay. First I'll integrate with respect to z, that is yz plus z square by 2. What are the limit points for that z? 0 to 5. Y is integration of y is 0 to 4 into dy. Next. Next, I'm substituting the z limit points, that is y is equal to 0 to 4, y of y upper point as 5, z upper point as 5 plus z upper point as 5 square by 2 minus of, we are substituting the lower limit 0, that is completely 0 into dy, right? That is equal to y is equal to 0 to 4, 5y plus 25 by 2 into dy. 5y plus 25 by 2 into dy. Next step, okay, with respect to z integration over, now I'll integrate with respect to y, that is 5 into, okay, y integration as y square by 2 plus 25 by 2 into y. What are the limit points for the y? That is 0 to 4. That is 0 to 4, right? Then here substitute the limit points, that is 5 into, once you observe here, yz integration with respect to z as yz plus z square by 2, after substituting that as y into 5 plus y square by 2 minus 0, right? And next integration with respect to y, that is 5 into y integration is y square by 2 plus 25 by 2 into y. Then substitute the limit points now, that is 5 into 4 square by 2 plus 25 by 2 into 4. We are substituting the lower limit, that as 0. Therefore, 5 into, okay, here 2, 1, 2, that is 5 eighths plus 2 twos are 25 twos are 50. Therefore, 5 into 8, 40 plus 50. Therefore, the final answer is 90. Therefore, the final answer, okay. Therefore, the given integral f bar dot n bar ds for the particular first octant in between the limit point z is equal to 0 to 5. Therefore, the final answer is 90. Okay. Therefore, integral s f bar dot n bar ds is equal to what? That is equal to 90. This is the first question answer. Once you observe here, the given question, the surface is included in the first octant between the limits z is equal to 0 to z is equal to 5. For that case, we got the final answer as 5. For example, for the same question, x square plus y square is equal to 16. That is the surface included in the first octant between the limit points are x. Okay, between the limit points are in between x 0 to 5 means, for that case we can consider the formula as related to x formula. Okay, first octant in between the y limit points. For that case, consider the formula in between the y limit points. That's the concept. No need to take always in between dy dz surface integral formula for the first octant. That is completely depending on the question. If it is in x-axis limit points, for that case we can consider first octant either xy or zx. Here the first octant in between y0 to 5 means, for that case y related formula, that is either xy or yz. Here the question is in first octant in between z. For that case I am taking either zx or yz. Okay, we are taken either yz or xz, we got the same answer. That's the first question answer is 90. If you have any doubt with respect to dy dz, I'll calculate it with the dy dz. If you want, then you can calculate if this is an dx dz. Okay, this is on dx dz, got the same answer. Okay, that is 90. Okay, now I'll explain one more question on the surface integral, that is evaluation of double integral of s f bar dot n bar ds, where what is f bar here? Okay, here f bar is equal to zi bar plus xj bar minus y square z into k bar, right? And S is the surface of the cylinder. Okay, here what is S? Surface of the cylinder, that is x square plus y square is equal to 1. Included in the first octant between the planes are z is equal to 0 and z is equal to 2. This is also same as the previous question. Here also what they are asking in the question, first octant between the limit points are z is equal to 0 to z equal to 2, and the cylinder equation is here x square plus y square is equal to 1, and f bar as zi bar plus xj bar minus y square z into k bar. In that case also same formula, that is integral as f bar dot n bar ds. Integral as f bar dot n bar ds is equal to double integral of f bar dot n bar into dz dy by, okay, modulus of n bar dot I bar. This is the formula. Okay, f bar dot n bar dz dy by modulus of n bar dot I bar, or yes, f bar dot n bar ds is equal to double integral of f bar dot n bar into dz dx by modulus of n bar dot j bar. This is also formula for related to z axis. Okay, generally I'll calculate the given question as in terms of yz. If you want, then you can calculate the same question with respect to zx axis also. Okay, but I'm calculating the given question with respect to the zy axis. Okay, let us start with the solution here. What is f bar? F bar is equal to zi bar plus xj bar minus y square z k bar. Okay, same concept here. Okay, let us assume the cylinder equation is here. Pi is equal to x square plus y square minus 1. Okay, then calculate del pi. That is I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z of, what is pi here? X square plus y square minus 1. That is I bar of dou by dou x into x square plus y square minus 1 plus j bar into dou by dou y of x square plus y square minus 1 plus k bar into dou by dou z of x square plus y square minus 1. Okay, then I bar into, again, differentiation I bar coefficient with respect to x, right? Then what is the differentiation for the x square plus y square minus 1 with respect to x? That is 2x plus j bar into, with respect to y differentiation, that is 2y, right? And with respect to z differentiation, k bar of z differentiation is what? There is no z term in the function, that is scalar point function, that is 0. Therefore, 2x I bar plus 2y j bar, that is del pi, right? Therefore, modulus of del pi is equal to what? Okay, then modulus of del pi is equal to under root of, here I bar coefficient as 2x, that is 2x whole square, plus j bar coefficient as 2y, that is 2y whole square, that is equal to what? The root of 4x square plus 4y square. From that I'll take 2 common, that is 4 common, that is 4 to x square, 4 into the root x square plus y square, that is equal to 4 into x square plus y square is equal to how much? From the cylinder equation, that is equal to 1. Therefore, root 4 is equal to how much? 2. Therefore, modulus of del pi is equal to how much? 2. Okay. Now, from the equation, now we got the first concept, that is del pi and modulus of del pi. Then, therefore, unit normal vector formula, del pi by modulus of del pi, right? What is del pi here? That is 2x I bar plus 2y j bar by modulus of del pi is how much? Modulus of del pi is 2. Okay, then I'll take common 2 from the numerator, that is xi bar plus yj bar by 2. 2 cancel, that is xi bar plus yj bar, that is n bar. That is n bar is equal to what? Xi bar plus yj bar. Next, f bar dot n bar. Okay, dot product with f bar dot n bar. That is, what is f bar here? Zi bar plus xj bar minus y square z into k bar. Dot, what is n bar? Xi bar plus yj bar. Xi bar plus yj bar. Then multiply or dot product with both. Here I bar coefficient as z and here I bar coefficient as x. Then multiply both, that is zx, that is xz, right? Plus here j bar coefficient as x and here j bar coefficient as y, that is x into y, that is xz plus xy. Once you observe here, for the first vector k bar coefficient as minus y square into z, but from the second vector, what about k bar coefficient? 0. That means here k bar as 0, k bar coefficient as 0. Therefore f bar dot n bar is equal to what? F bar dot n bar is equal to xz plus xy. Okay, xz plus xy. Now we know that each and every point from the formula, that is f bar dot n bar is xz plus xy and modulus of n bar dot I bar. Okay, then here next, modulus of n bar dot I bar. What is modulus of n bar dot I bar here? That is n bar as xi bar plus yj bar dot I bar. That is, here I bar coefficient for the first vector x and from the second vector 1. That is x into 1. Therefore, modulus of n bar dot I bar is equal to how much? X. That is equal to x. Okay, now we know that f bar dot n bar and modulus of n bar dot I bar. Therefore, here we have to calculate the surface integral on yz axis. Yz axis means already from the question, z limit points are 0 to 2. Okay, z limit points are 0 to 2. And what about the y limit points? Now we are calculating the y limit points from the cylinder equation, right? Here, x square plus y square is equal to 1. From that, let x is equal to 0. We got y limit point 1. Therefore, y passes through 0 to 1. Therefore, y it is passes through the 0 to 1. Right? And next, what about the z limit points directly given in the question? That is, z limit points are 0 to 2. Z limit points 0 to 2. Therefore, y is 0 to 1 and z limit points are 0 to 2. Okay. Then substitute here in the above formula, that is integral s f bar dot n bar ds is equal to double integral of f bar dot n bar modulus of n bar dot I bar into dy dz. That is equal to what? Y limits are 0 to 1 and z limits integration of z is 0 to 2 f bar dot n bar as xz plus xy into dy dz by, what about modulus of n bar dot I bar? X, right? That is x. From that, y is equal to 0 to 1 and z is 0 to 2. Here what is common? X is common. That is z plus y into dy dz by x. Right, here x cancelled, then y is equal to 0 to 1 and z is 0 to 2. Okay, then function is here y plus z into dy dz. Y is, that is the function is y plus z into dy dz. Okay, now I'll integrate first with respect to z. That is, first I'll integrate with respect to z, that is integration of y is equal to 0 to 1. Okay, with respect to z means y is constant, here 1, that integration as z plus z square by 2. What are the limit points for the z? Z is 0 to 2 into dy, right? Substitute the limit points, that is y is 0 to 1, integration of y is 0 to 1, y of z as 2 plus 2 square by 2. And the lower limit is 0. If you are substituting that 0 also, completely that as 0 into dy. That is integration of y is 0 to 1, 2y plus 1 to 2 cancel, we got 2 here into dy. Okay, then the next continuation here, integration with respect to y. Okay, that is 2 into y square by 2 plus 2 integration with respect to z, that is 2y. Right? Whatever the limit points, 0 to 1. Limit points are 0 to 1. Therefore, here 2 to cancel. 2 to cancel, then substitute the limit points. First point as upper limit 1, that is 1 square plus 2 into 1 minus of 0 plus 2 into 0. Right, that is 1 plus 2 minus 0. That is equal to how much? 3. Therefore, integral s f bar dot n bar ds is equal to what? Final answer for this question, 3. Okay, this is the concept of the surface integral for the first top 10. First top 10 means not only dy and dz, if it is in related to the given limit points, right? Okay, this is the final answer for the second question. Integral s f bar dot n bar ds is equal to 3. Okay, next class we will discuss the next concept as volume integral. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.